In this video, we're going to expand on working with negative exponents. And let's start off with this one. We need to simplify x to the minus 2 divided by x to the minus 7. Now I'm first going to show you a typical textbook approach. And you'll find it's a little more trouble than is really necessary, but it does work, of course. So a textbook approach would be to say, okay, well, we're dividing. That means we're going to apply the quotient rule. The quotient rule means that we're going to, when dividing two numbers of the same base, we're going to keep the base and subtract the exponents. So my base is x, and I subtract the exponents. There's always a top exponent minus the bottom exponent. And here's where people goof. Now, another one of those common errors students make, all right? One that you could very well likely make is right here. Students, particularly those who seldom practice much, tend to write this as minus 2 minus 7, but that's not quite right. You're subtracting minus 2 minus negative 7. We're subtracting a negative, so this would be wrong. This would give you minus 9, and up here we're going to end up with a positive 5. All right, so well, let's finish it. We're subtracting negative 7, so the two negatives side by side will cancel. Negative 2 plus 7 is x to the 5th power. Okay, now that's really not a lot of work, but let me show you another approach, which I think in time you'll find is it may save a step or two, and also may prevent some careless errors. So here's an alternative approach to thinking of this. I'll rewrite the problem down here. X to the minus 2 divided by x to the minus 7. We observed in the last video that when you change the sign of an exponent, it reverses the position in the fraction. So in other words, if I change this to a plus 2, I've got to bring that downstairs. If I change this to a plus 7, it has to come upstairs. And so when I do these problems, I just instinctively flip things around. The ones that are negative, I switch positions. So this comes upstairs, it's x to the 7th. That goes downstairs, x squared. And guess what? X to the 7th over x squared is x to the 5th. Of course, that's 7 minus 2. So anyway, that's an alternative way of looking at it. I really don't care which one you use. If you're my student, it's up to you. And I just want you to do good math. But I think if you take the time to learn this, you'll make fewer of these types of careless errors that I pointed out a minute ago. All right, well, let's do a couple more of these. And I'm going to erase this and put another one on the board. Usually these problems, you're asked to simplify. And simplify in the context of these problems means to leave your answer with with positive exponents. And so if you want full credit from me, you would leave the problem with all positive exponents. And so let's see what happens here. Now I have x to the minus 2 divided by x to the positive 4. So don't go overboard about moving things around. If you like the method I showed you in the previous problem, you can say, all right, well, let's change this minus 2 to a positive 2. That means this comes downstairs. However, the x to the 4 stays where it is. It already is a positive exponent. So we end up with x to the 2nd times x to the 4th downstairs. But what about upstairs? What about the numerator? Well, we need a 1 there, and there's still a number there, and ends up being 1. It would be easy to justify this by various ways of doing it. Anyway, 1 over x to the 6th would be our answer, because now we're going to multiply these two terms. The product rule applies, which means we add the exponents to them. All right. Well, let's do another problem, a little more complicated this time. Well, this one is a celebration of negative exponents. Let's read through it. Simplify, parentheses, z to the negative 3rd power raised to the minus 2 power times z to the negative 8 all this divided by parentheses z to the minus 4 raised to the third power times z to the fifth. And notice the way I write my z's with a little slash mark through it. I do that because if I didn't, my z's and my 2's would end up looking pretty much the same. So because the way I write my 2's, I've adopted this way of writing z's. Now you may need to do some similar things, the way you write things. I've seen some people, their 6's and their letter b's look about the same, and that can be a problem once in a while when you have a letter b in a problem. There's a few others like that. People have their quirks in writing, so be careful. I've seen people confuse letters and numbers before, and this is my way of not confusing z with 2. All right, well, what are we going to do here? I would think probably, well, we really have a lot of flexibility, but I'm going to go ahead and apply the power rule here and remove these parentheses. So we could do other things here. We could change these exponents to positive. We could do some simplifying, but I think I'm just going to go ahead and apply the power rule. So we'll take care of the parentheses first. So z to the minus 3, when I raise it to the minus 2, when I remove the parentheses, the power rule says we need to multiply exponents. So that's going to give us a positive 6. So I have z to the positive 6 times z to the minus 8 over, here same thing, same story, multiply exponents, z to the negative 12 times z to the fifth. Okay, it's looking a little better already. I think I'm just going to go ahead and multiply across and let the chips fall where they may. So z to the 6 times z to the minus 8, we add exponents. 6 plus negative 8 is negative 2. And z to the minus 12 times z to the fifth is z to the minus 7th. Okay, well actually that looks like our first problem, doesn't it? That I did in this video. You could switch positions around, z to the 7th over z squared, and we get z to the 5th power. So just like we did before, except that was with x's. Anyway, that's one way of doing this problem. There are, of course, other ways. We could have moved these negatives around if we wanted to. That would have been fine. In fact, let me just show it this way as an alternative. We'll come down here. If I move this one and this one, because those are the two with negative exponents, then on top we would have z to the 6th times z to the 12th over z to the 5th times z to the 8th. And then if we multiply across, we get z to the 18th over z to the 13th by adding exponents and then subtracting exponents. 18 over 13, subtract, we get z to the 5th again. So again, you've got some flexibility in working exponent problems in the order in which you do them. All right, well, our last video in this section is going to put everything together.